Hi, pre-calcers. All right, so today we are going to be dealing with equations of ellipses. So first thing we need to tackle is what is an ellipse? And an ellipse is a conic section, and that is an oval shape. All right, so the major axis is horizontal, like the one that I just drew, where it's saying the longer side is on the horizontal. And then, I zoomed in on that one. The major axis is vertical. All right, so we've got the major axis is horizontal. That means that my major axis is horizontal versus my major axis is vertical. Okay, so we've got the equation of the ellipse are given. They're both going to equal 1. And depending whether the major is horizontal or vertical, the A is going to be under the X if it's horizontal versus the A is going to be under the Y if it's vertical, and A is going to be the bigger number. All right, so A squared and B squared switch depending on whether it's horizontal or vertical. All right, so H comma K is going to be the center of the ellipse, just like we used H comma K as my vertex of the parabola. We also had H comma K in our equation for a circle way back in section 1.1, so that was at the beginning of the year. And just like in parabolas, last section we talked about a parabola has a focus, which is inside of the parabola, that point. The plural of focus is actually called foci, and an ellipse will have 2 of them, and they lie on the major axis using the foci. All right, so the equation for finding C, and C is the distance from the center to the foci. So the way that we find C is going to be C squared equals A squared minus B squared. Careful, it's not A squared plus B squared. That is our Pythagorean theorem. This is A squared minus B squared. All right, so let's actually look at what equations are so that we can apply this. All right, so we've got number 1, we've got x minus 3 squared over 36 plus y plus 1 squared over 9 equals 1. All right, so first thing I do is I'm going to identify my center. My center is h comma k, so it's going to be 3 comma negative 1. I'm going to just change that to blue to graph it. So I'm going to go to positive 3 comma negative 1. And plot my center of my focus. Sorry, my center of my ellipse. All right, my major axis, since the bigger number is under the x, my major axis is going to be the x's. So the length, the way that I find the length is I'm going to take the square root of 36. So A is equal to 6. And I'm going to go from my center point. I'm going to count 6 units to the right because it's the major axis is the x, so I'm going to go along the x's, 6 units to the right, and then 6 units to the left. So 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. So the length of my entire major axis is going to be 6 this way, 6 that way, 12. Now my minor axis is my y, all right, and my b, well, b squared is 9, so I take the square root, so my b is 3. So what I'm going to do is, since my minor is the y, I'm going to count up from my center 3 units, and down from my center 3 units. So 1, 2, 3 units up, 1, 2, 3 units down. Okay, and those will be my length of my minor axis. So if it goes 3 units up and 3 units down, that's a total length of that minor axis of 6. All right, so now another terminology is called the vertices, and that is the major axis endpoints. So my major axis endpoints are going to be 9, negative 1 from when we counted 6 to the right, and then 6 to the left was negative 3, negative 1. So those are right there and right there. My minor axis endpoints are going to be 3, 2 from when we counted up 2 from my center, and 3, negative 4 from when we counted 3 down from my center. All right, now my foci are probably going to be a little bit more difficult to find. So my foci, I do c squared equals, so I'll do the work down here, a squared, which is 36, minus b squared, which is 9. So that's 27. So c squared equals 27. And then I take the square root. So c is going to equal approximately, and we'll just kind of approximate it to 1 decimal place so that we're not like, you could do it as like 3 radical 3, but I'm going to do it as a decimal point so it makes life a little bit easier for us to visualize where is it going to be. 5.2. All right, so my foci, I'm going to just change the color. So since my C is 5.2, what I'm going to do is I'm going to count 5.2 from my center to the right, because it should be on my major axis, and then 5.2 to the left. So 1, 2, 3, 4, 5.2. So my foci is going to be right there. And then 1, 2, 3, 4, 5.2. So my foci is going to be there. So my foci are going to be at, when we add 5.2 to the right, we get 8.2, negative 1. And when we subtract 5.2, aka going to the left, you're going to get negative 2.2, negative 1. So we add and subtract 5.2 from my x value because you're traveling along the axis. Okay, so now last thing is to create that ellipse, and it's going to be, I'm the worst at connecting all these, so, okay, not that bad. All right, usually they're brutal. All right, so that is my ellipse. It should look a little bit more ovally, but what can you do? All right, next one, we've got the equation. And if you look at the equation, the bigger number is under the y. So it's going to be a vertical. The major axis is vertical. So my center of this one is going to be 6, negative 3. So I go to 6, negative 3. 1, 2, 3, 4, 5, 6, negative 1, 2, 3. And there's my center point. My major axis is going to be my y's because my bigger number is under my y's. So my A is going to be the square root of 16, 4. So I go up and down because it's on the y's, so the y's should be changing. So I'm going to count up and down 4. 1, 2, 3, 4. 1, 2, 3, 4. So my major axis is going to be vertical. And if it goes 4 up and 4 down, that's a length of 8. Now my minor axis is going to be the x's. So my B is 3. So I'm going to count 3 to the right, 1, 2, 3, and 3 to the left, 1, 2, 3. And that is I'll zoom in a little bit so that I can draw that a little bit more accurately. That's my minor axis. So if I go 3 to the right and 3 to the left, that's going to be a length of 6. All right, so now we've got the vertices, so my endpoints of my major. So my endpoints of my major, when I go up 4, I'm going to, the first one is at 6, comma, 1. And I go down 4, so it's going to be 6, comma, negative 7. My minor axis endpoints are, I went 3 to the right, so 9, comma, negative 3, and 3 to the left, 3, comma, negative 3. Whoop. All right, and now my foci, I have to do c squared equals, and then a squared minus b squared, so 16 minus 9. So c squared equals 7. So c is going to equal the square root of 7, which is approximately 2.6. So I'm going to just change the color to do my foci. So I'm going to count on my major axis. Remember, it's on my major axis, which is the y's. 2.6, 1, 2.6, up, and 2.6 down. 1, 2.6. All right, so, because my foci should lie on the major axis, so my foci are going to be 6, comma, 2.6 up gives me negative 0.4, and 6, comma, 2.6 down gives me negative 5.6. All right, and then the last thing is just to connect those dots to create that elliptical shape or the oval shape. Oh, this one's going to be a little dicey. All right, so this one, I missed that top point a little bit, but hopefully you guys do a little bit better. So this is a little bit less of an oval shape. It's a little bit more round than narrow, because if you notice, the A and the B are closer. A is 4, B is 3, so it's 4 up and down, 3 right and left, versus this one was 6 and 3, so 6 right and left, 3 up and down. So it changes the shape depending on how close the A and the B are. All right, guys. So what I want you guys to try are the next 4 of these graphing ones.